Welcome! So now we're going to complete some coordinate proofs with rectangles. Let's talk about rectangles first. So a rectangle is a parallelogram with 4 right angles. So that's its definition, but it has more features than that we could use to prove a quadrilateral was a rectangle. First, all of our proofs are going to require that we show that the figure is a parallelogram first. Right? Because a rectangle is a special type of parallelogram. Right? So other figures besides rectangles have some of the same features as a rectangle. What's special about a rectangle is it's also a parallelogram. Right? So the two features that we could use to prove a parallelogram was a rectangle is the fact that, first of all, parallelograms have congruent diagonals. But so do isosceles trapezoids. So if we're using the fact that rectangles have congruent diagonals, we're going to first prove it's a parallelogram. And then show it's a rectangle by showing that it has congruent diagonals. Now, what formula would we use to show that that anything is any segments are congruent? That would be the distance formula. So now we have to pick a way to prove that the figure is a parallelogram. And we have 4 to choose from, as we saw in the previous set of videos. I like to stick to the same feature or choose the method that would go best with the method I'm using to prove rectangle. So since we're using diagonals for the rectangle part, let's use diagonals for the parallelogram part. And that is, we're going to show that both diagonals are bisected. And what formula would we need for that? We would use the midpoint formula. The second feature of a rectangle that we could use to prove a figure on the coordinate plane was a rectangle is the fact that rectangles have four congruent right angles. Right, so if we're showing that the only angles we can prove anything about on the coordinate plane are right angles. Right? Because we can use the slope formula to show lines are perpendicular, and we know perpendicular lines intersect at right angles. So if we're going to show that this parallelogram has right angles, let's stick with the same formulas for the parallelogram part. So for the parallelogram part, let's show that both pairs of opposite sides are parallel. And what formula do we need for that? Well, that would be the slope formula. And then we can show it's a rectangle by showing that consecutive sides are perpendicular, which will show that they meet at right angles. And we know a rectangle is a parallelogram with 4 right angles. And how do we show lines are perpendicular? We use the slope formula and show that the slopes are negative reciprocals. All right, so in the rest of this video, I'm going to do proof of the first situation. We're going to prove that the figure's a parallelogram by showing both diagonals are bisected. And then we're going to prove it's a rectangle by proving the figure has congruent diagonals. We do need both parts, right, because we want to prove that this is a rectangle, not just any old quadrilateral that has congruent diagonals, because then it could be an isosceles trapezoid. All right, so here, this was in your notes. All right, and so we're going to use method 1 here. Show that the diagonals are congruent because first we're going to show it's a parallelogram. Then we'll show the diagonals are congruent because a parallelogram with congruent diagonals must be a rectangle. In the next video, we'll show method 2. All right, so step number 1 is always, if it's not already graphed, graph the figure. So you're going to graph the points 1, 1, and label that G, 5, 3, and label that H, 4, 5, and label that I, and 0, 3, and label that J. And then connect. Right, now, usually I use a line tool, but this is not a very large figure. Oops, the G's kind of in the way. See if we can get rid of the G. And I will just try to draw it very, very carefully. All right, so this is G here. All right, so this is step 1, graph. All right, so that way we can see the relationship of our points. When we graph, we know we connect them in order. All right, so G, H, I, J. And then because we are working with rectangles, with diagonals, let us let's graph the diagonals. Make that second one there a little better. Well, come on, will it move down? Doesn't want to. Wants to do everything else. Oh, I guess they're connected, unfortunately. That looks a little bit better. All right, so we have our diagonals graphed. Right, and then we go through, so that's step 1. Then we go to step 2. Step 2 is what do we want to show? We want to show, we got 2 parts here, a parallelogram by proving diagonals are bisected. Actually, let me put both diagonals. Although there's only 2 diagonals and plural kind of implies to the both. But let's put both. Both diagonals bisected. And B, rectangle diagonals are congruent. All right, so let's write down the formulas for each piece. So for A, how do we prove the diagonals are bisected? What formula would we need? We need the midpoint formula. All right, so midpoint formula. The midpoint, I'll just abbreviate that, mid, is equal to the average of the x-coordinates, so x1 plus x2 divided by 2, that would be the x-coordinate of the midpoint, and then the average of the y-coordinates, y1 plus y2 divided by 2. All right, so that we need that to prove the diagonals are bisected, because we have to show they have the same midpoint. And then to show the diagonals are congruent, we need the distance formula. And the distance formula is the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. Oh, I just fit that in. All right, so there's our formulas. Once we write our formulas down, we show our work. All right, so we're going to need to show that both diagonals have the same midpoint. So we graphed the diagonals so we could see the two diagonals. So our first one, we want the midpoint of IG. All right, so we're going to add the x-coordinates, divide by 2, and add the y-coordinates, divide by 2, and that's going to give us the midpoint. All right, so that would be, so IG would be 4 plus 1 divided by 2, and 5 plus 1 divided by 2. All right, and so 4 plus 1, that's going to be 5 halves. 5 plus 1 would be 6 halves. Let's simplify the 6 halves. So 5 halves 3 is the midpoint of IG. Let's find the midpoint of the other diagonal. So the other diagonal is JH. All right, so we add the x-coordinates. So that would be 0 plus 5 divided by 2. And add the y-coordinates. So that would be 3 plus 3 divided by 2. All right, so 0 plus 5, that's 5 halves. 3 plus 3 is 6 halves. And they are the same, 5 halves 3. So now we have, with our work, we've shown that this is a parallelogram because both diagonals are bisected. We need to explain that, but we've got the work to back that up. And now we need to now show that this is also a rectangle by showing the diagonals are congruent. So we're going to use the distance formula. And so we have the length of IG. Right? So we just take the difference in the x-coordinates. It doesn't matter who's x2 and who's x1, who's 0.2, 0.1. Just be consistent. All right? So I'm just going to go in order. All right? So G's first, so I'm going to write 1 minus 4 squared plus 1 minus 5 squared. So difference in the x's from I to G, difference in the y's from I to G. And that would be 1 minus 4 is negative 3. The whole thing is squared, including the negative, plus 1 minus 5, that'd be negative 4. Whole thing is squared. So negative 3 squared, that's 9. Negative 4 squared is 16. Add them together. That's 25. The square root of 25 is 5. Let's do the same thing, but with the other diagonal, JH. All right, so difference in the x-coordinates squared. Again, I'm just going to go in order. So the h is first when I read it, so I'm just going to start with h. So 5 minus 0 squared plus, and then 3 minus 3 squared. 5 minus 0 is 5 squared, plus 3 minus 3 is 0 squared. I don't need that. So that's going to be the square root of 25, which is 5. All right, so now we have the work to justify that the diagonals are congruent. And we know that a parallelogram with congruent diagonals is a rectangle. So now we just need our step 5, which is the proof. And I'm going to do this one as a 2-column proof. All right, so we have statements, and we have the reasons. And all of our statements just come either from our work, they literally are the work, or they are a fact based on the work. Right? So always start with your given, we were given the figure GHIJ. You don't have to write down the points. It's fine to write GHIJ. Right? So we're just saying that quadrilateral, we were told those points. And so that is a given. All right, and then what did we do next? We found the midpoints, right? So the midpoint of IG is 5/2, 3. And the midpoint of JH is also 5/2, 3. Well, how do we know that? How do we come up with those midpoints? Well, we use the midpoint formula. So you see, everything is either you're based on your work or based off of your work. So what if they have the same midpoint? Well, if they have the same midpoint, that means that the diagonals bisect each other. How do we know? Bisected diagonals, or any segment, doesn't even have to be a diagonal, but bisected diagonals have the same midpoint. So what if they have the same midpoint? So what if the diagonals bisect each other? Well, if the diagonals bisect each other, that means that GHIJ is a parallelogram. How do we know? It's one of the 5 ways to prove, actually 6 ways to prove that a figure is a parallelogram. We had 4 ways, though, that work on the coordinate plane. And this one is a quad whose diagonals bisect each other. You've got a quadrilateral whose diagonals bisect each other. We know it has to be a parallelogram. It's only true for a parallelogram. All right, so, but we're not done. We proved it's a parallelogram. We have not proved it's a rectangle. All right, so then what else did we do? We found the length of IG. IG is 5, and JH is 5. How do we know? We use the distance formula. So what? They have the same length. Well, that means they are congruent. I'm going to extend the board just a little bit. There we go. That's more than I wanted to extend it. I'm going to make sure we can still see the work. There we go. But I have enough room to write. I'm almost done. I just have 6 and 7 are it. So IG is congruent to JH. Really should have, actually I don't need them where I'm telling the measurement. Right? So if you're saying measurement, it doesn't get the symbol for a segment. But once I'm talking about that they're congruent, I should really have the segment to show it's a line segment. So IG is congruent to JH. How do we know? Congruent, I'm going to abbreviate that. Congruent segments have the same measure. I'll put equal for same. Have equal measures. So what does that mean? It means that we called it GHIJ. GHIJ is a rectangle. How do we know? It's a parallelogram. I'm going to abbreviate that P-gram. P-gram with, that's the abbreviation for with, congruent diagonals. And there we go. This one is done. Right, in the next video, we'll complete the second proof, and that will be it for rectangles. We only have 2 ways to prove rectangles on the coordinate plane. All right, thanks for watching. Bye for now.